Hello everybody, my name is Stelios Antoniadis and together with George Hainis and Nikos Halazonitis, we created the Deus Ex Machina.
When natural disasters or wars occur, there are thousands of civilians trapped. Sometimes it's impossible for them to leave the destroyed area, so outsiders have to help them survive. The trapped ones lack medical supplies, for example, insulin and health medications, clothing, and even consumables, most importantly, water. An example is the war in Ukraine, where less than 3% of the residents of Mariupol have access to clean and drinkable water. So we started questioning ourselves whether we can relieve trapped people with the use of robotics and artificial intelligence by providing them with supplies without using manned vehicles. Inspired by Deus Ex Machina, the godly occurrence used in ancient tragedies that helped people in times of crisis, we provide a similar modern real-world prototype.
First of all, a drone scans a destroyed area, which is then represented in the form of a two-dimensional map on our screen. From this map, we gain very useful information, such as the road's adjacency, their length, and we can even determine the risk of passing from them, for example, whether the road is a war zone. All this data are then utilized by our A-star algorithm that returns the shortest and safest path, depending on the parameters given by the user. Our rover follows the path and we successfully provide help to the trapped people.
The A-star algorithm is a search algorithm. In graph applications, the A-star algorithm returns the shortest path from a node N to any destination. The heuristic that we use for our pathfinding is the Euclidean distance from a node N to a destination. This heuristic is admissible as it cannot overestimate the total distance from the node N to the destination, as the Euclidean distance is actually the shortest distance. Our heuristic is also consistent or monotonic. Lastly, in order to find the safest and shortest path, we apply pruning method to all roads with high risk. Here you can see our A-star algorithm written in Lua for our simulation. In this line we can see the estimated cost function with the addition of the heuristic. And in this line we can see the pruning of all roads with a very high risk of passing through them. So Nick, we mentioned something about the risk of passing through a road. What is it and how do we determine it?
As we mentioned before, a drone scans the area and takes pictures of it. Through this scan, we have the ability to create a two-dimensional map. Apart from the length of the roads, we can also clearly see what obstacles are on each road. From these obstacles, we can determine the risk of passing through each road. But how do we determine it?
In our prototype, we have set the limits of risk that are from scale 1 to 4. We have also said that a clear road has a risk of 1, a road with water or mud on it has a risk of 2, a road that is either destroyed or flooded or has foreign debris on it is considered to have a risk of 3, and a road that is either a war zone or has a military outpost has a risk of 4. With the use of machine learning, we have trained a model to clearly recognize the obstacles on the roads and return for each road the name of the obstacle on it.
We created our model and trained it through the use of one tool named RoboFlow. In order to recognize the roads live, we use computer vision, where the RoboFlow model sees the screen of our computer, which is our map. The computer vision shows live on our screen the objects contained on each road. With the use of these estimates, we determine the risk of passing through these roads. Here, we can see how many images we used to train our model.
Our simulation has been created in Roblox Studio. On this part of the simulation, you can see the shortest path. The path, which is excluding roads with risk level of 3. The path, which is excluding roads with risk level of 2. No path is returned, since to reach the target, the rover has to pass through a wet road, and the safest path. Now this is a different map, and here you can see the safest route to the target using the map with the different danger levels. As all AI projects, our project follows AI's 5 big ideas. Our AI system perceives the world using cameras. Using object detection, it enriches the map so as to create a weighted graph with nodes and edges. We use knowledge from a computer vision model to deduce a path shortest and safest for our robot. Our system could interact with people so that they send or ask for supplies. And finally, natural disasters and wars result in human tragedies. Relief of pain, hunger, etc. is a true challenge for AI. AI should always be in the service of mankind.
At this point, we have reached the end of our presentation. We hope you enjoyed it and were fascinated by our idea. Bye.